So this is the actual graph that you've got examples of in your book, okay, on that sheet of paper that I've given you. Now what we want to consider is, we know how to graph this kind of thing, but we're not going to consider the graph of this as the important part. We're just going to use it as a building block and then transform it, map it to something else based on this, okay? So therefore, instead of saying, look, my y-axis is going to be defined by this, okay, we just say, we'll call this f, we'll define this f, and then what you are going to draw will be different kinds of f. So we'll start very simply, right? Let's have a look at this guy. This is about as simple as it gets. And you can even try to picture what's going on, right? The two approaches you're going to have are algebraic and visual, okay? Algebraic is kind of like a crutch. You don't want to rely on it because it's very slow, as you'll see in a second. Here are my keys. Thank you. Did you find them?
Yeah, fine.
Great. It's a very slow way to approach it, but you'll know exactly what it's looking like, and then you can use that sort of as a means to be more comfortable with just looking at it and saying this is what it's going to do. So let's look at this. Let's think about this, number one, in an algebraic way. What does this mean? All it means is minus, well, we already defined f of x, didn't we, right? So it's 2x plus 3. So here's my graph. That's what I want to draw, okay? So if you have a look at your first, on the little sheet there, right? I'll draw it up so that you can see it on the board. Two x plus 3, you've got your intercept up there at 3, and because of the gradient, you're intersecting over here at negative 1.5. Okay. So now when you compare this to this, what's this going to look like? Have a think about the features. What do you think is the most important feature that you'd put on there straight away? Y-intercept, very good, okay? So that's at negative 3, reflected across this way, right? So you're going to intersect through here. And because you've got a gradient that's exactly opposite to this, right? It's going to come down at exactly the same angle that this comes up, right? So therefore, you're getting this kind of shape. Okay, so what's happened? How would you articulate in words what this transformation has done to the original graph? How would you word it? Shishing.
Reflected on the x-axis.
Yeah, fantastic. Okay, so this is reflection across the x-axis. Okay, nice, easy, right? Now, let's keep on pushing on that. Let's think about, well, how does this principle work? For instance, if I wanted to reflect it across the x-axis, this is what I would do. What would I have to change in order to reflect it across the other axis? So, let's have a think about this. Y equals f of negative x, right? Now, can you see how this is similar, but just different enough that it's going to have a different effect for us, right? So this negative over here, another way of thinking about it, is that it modifies y, like so. Okay? Good morning. So the reason why I placed that there is so that you can see reflection across the x-axis is a perfect technical way of describing what's happening, but just visually I like to say that's being flipped vertically. That's the way to think about it, okay? It's being flipped vertically. That's what I'm modifying, right? So therefore when you see this, see how the negative is modifying your x value? Well, you can immediately say, you can instinctively say, I'm not going to be flipping vertically anymore, I'm going to be flipping horizontally. Now let's just verify that because we can use this algebraic approach, right? So, what does f of negative x mean if that's f of x? What should I write down on this next line? Good. I'll just go one step before that. I'll just go the straight substitution, which is 2 whatever, right? 2x, u, e to the x, negative x, whatever it is. And then plus 3, okay, which of course gives you that negative 2x plus 3 that you were just telling me, okay? So now when you graph this against the original, okay, 2x plus 3 was here, minus 2x plus 3, okay, think about it. It's got the same y-intercept, so there you are, right? But of course, we flip the gradient around, right? Just like we did before, so this is the shape that you've got, which as we just suggested, as we just proposed, is flipping horizontally. as opposed to flipping vertically. Okay? So, the way I like to think about it is, you've got this graph and it's behaving in a particular way, right? And then your transformation modifies its behavior. It's still the same thing, but it's just been twisted around in another direction, right? So you've got your original features there. This value over here is going to be important. One of the things that markers look for is the critical features of the graph, not just the general shape, but that you know that this is exactly the reflection of that, right? And that's important. That's one of the reasons why on the graph you'll get provided, as I provided to you this morning, they'll provide to you the scale, okay? The scale is kind of like, it's the principle of giving someone enough rope to hang themselves. So you might think, oh cool, there's a scale there, that's nice of them. Actually, they're making it harder for you because you have to be precise. If they provide you the scale, they expect you to make sure that 1.5 is on 1.5, okay? And there's a reasonably low threshold for error, okay? Yes?
So will we have to draw the graphs or just mark them on the scale they provide?
Okay, so almost certainly, in the HSC, because they have sort of, it all gets printed out and all that kind of thing, you will have to draw your own one, and it will get scanned in and so on. But for us, we're probably gonna provide you graphs, okay? Just as a general rule, the harder the graph becomes, like I'm giving you very simple ones to begin with to illustrate the concept. The harder it becomes, the more we're going to provide your graph, so you don't get hung up on the original graph, and so you can focus on the transformation process. Does that make sense?